So I went ahead and did the calculations for this. I went around and counted all the singles, and I had 29 full squares. And I counted the 3/4 with this little mark here. Okay, these are each 3/4. And I counted that there were 6 of these spaces that had 3/4 of a square. I then went around and counted the half squares, and the half squares I did with the X's here. Okay, those are about half squares, and I counted about 12 half squares. And then I went around with the dots and counted the quarter squares. So if you take 29 times 1, you'll get 29, or again, these are going to be different for you. You take 0.75 and multiply the number that you got. I got 4.5. You take 0.5 and multiply it by the number of half squares that you got. I got 6. And then you take 0.25, multiply it by that number to get the number of quarter squares. Then you add them all together. Okay, so that's the first step. Okay, we just calculated our area. If you could turn your sheets over. And my area is equal to 41.75 square inches. Now we need your weight. My weight is equal to 179 pounds. If you're looking at, again, pressure in terms of English units, it's still the same formula. Pressure is force over area. But what they do is they use the force as the weight from your scale. So this is going to be 179 pounds divided by the area in inches. Mine's 41.75 inches squared. And then if you can go on your calculator to do this, and I get 4.29, and again, it is in pounds per square inch. So this is, again, the English. This is PSI, or we can say pounds per square inch, PSI. What we want to do, though, is we want to convert this pounds per square inch into pascals. So remember, pressure is equal to force over area, but we want to get this in terms of newtons and meters squared. Okay, let's take a look at force. From previously, we know that force is equal to mass times acceleration. So the mass times acceleration is going to be on the top, and the area is still going to be on the bottom. So when we're taking a look at pounds per square inch, pound is sort of like mass, and inch is an area. Pounds per square inch really calculates this without the effect of acceleration. So Newton is a force, but pounds actually, technically, is a mass. It's not truly weight because it doesn't have the factor of acceleration. So we're going to be plugging that in. So we're going to be starting with your pounds per square inch, 4.29 pounds per inch squared. And now what we need to do is that we need to multiply by acceleration. So acceleration is 9.8 meters per second squared. This looks a little messy with all the units, but it's all going to come out to be newtons and meters squared. So let's remind ourselves also of what a newton is. A newton is, again, mass times acceleration. My mass is measured in kilograms, and acceleration is measured in meters per second squared. Well, we already have the meters per second squared. We just need to get the kilograms. So we can do a conversion and get rid of the pounds and convert them into kilograms. Pounds and kilograms. 1 pound is equal to 0.45 kilograms. So you have your PSI multiplied by the acceleration, multiplied by the converting unit. We'll go ahead and cross off those pounds and cross off those pounds there. Now I have a kilogram meter per second squared. That's actually a Newton. That's my Newton right there. But I need to convert my inches squared to meters squared. And this is going to take 2 conversions to do this. So we need to convert inches into centimeters. And 1 inch is equal to 2.54 centimeters. What we need to do, though, is we need to square this and square this. Because we don't have inches, we have inches squared, and that will give us centimeters squared. So those cross off with those there. And then the last step is converting from centimeters to meters squared. So we have centimeters here, we have meters here. 1 meter is equal to 100 centimeters. But we still need to square this and square this. I'm not going to cross off the centimeters squared because I have to remember when you're squaring these values, they have a numerical value, but they also have a unit. We're squaring the number and we're also squaring the unit. So if I crossed off the centimeters squared, I might forget that I have to apply the squared to the 100 as well. Same thing down here. We need to apply the squared to the unit as well as to the number. So take all of this and see what you guys get. And I end up getting 29,324, and I'm left with units of kilograms, meters per second squared, which is a Newton, all over meters squared. This gives me my Pascal, which is newtons per meter squared. We can also convert this into kilopascals, and we have 1,000 pascals is equal to 1 kilopascal. We can just move the decimal place over 3 like this. So this would give us about 29.3 kilopascals. Yours should be probably, hopefully, somewhere between 20 kilopascals and 40 kilopascals, depending upon your weight and also depending upon your shoe size.